In this video, I'll be working through the question you see on the screen here from the 2025 Leaving Cert Higher Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video if you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. I love question A in part 6. It simply is sine A is equal to a half. What is the angle A? Your calculator will do this for you. Put this into your calculator and you will get A is equal to 30 degrees. Problem solved. Except it's not. You're going to get very few marks for that. Because they specifically asked, they highlighted it in bold, to find 6 solutions to this question. And this is all you got. They helped you out by saying A is actually bigger than minus 360 and it's smaller and less than 720 degrees. Find 6 answers. So what are you doing? This question comes up every year in the Leaving Cert. Not usually, like I've never seen it done like this. Usually it's a harder question, but at the end then you have to get a few different answers. You have to do what we're going to do here. In this case they ask you for 6 straight up, no tricks. Just get 6 to this simple question. So here's the trick. Let me draw sine of A. You've hopefully seen this before. Let's put a nice long line here. Sine of A starts at 0 and it's bumpy like this. Now importantly, it goes on forever that way, and it also goes on forever this way. That's what sine A looks like. A half is just the value around here. That's half. So the answer to this question is, when is sine A a half? Well, right here it is. Also here, and here, and here, and here, and sorry, this is too low. It should be halfway between those. And here, and here, and here. And there's millions of answers. There's infinite answers to this question. Your calculator is just stupid. It only gives you this one answer. That's probably not fair. There's probably some calculators nowadays that will give you as many of these answers as you ask for it, if you know how to use it. So what 6 answers do they want? The secret's here. 360 to 720. Sine starts at 0 and it repeats every 360. There's 360 there. There's 720 here. There's minus 360 down here. So let me put 360 down here. So just from the image of the question, what 6 answers are they looking for? Well, there's 1, 2, 3, 4, 5, 6. They don't care about these ones. They don't care about these ones. They're the 6 you're looking for. 30 is one of those answers. Let's start down here and get them all. A is equal. To get these, it's not difficult at this point, but I think students do fall at this last hurdle. We use our calculator to find this first one, and then I use symmetry. I use the idea that, well, I know this length here is 30. And this is the same length between there and there, between there and there, between there and there. All of these lengths are 30. If you see what I'm saying, this length is all 30. And we know this number is minus 360. So this number here must be minus 330. I'm just using the fact that I know it's 30 away from this point. This point here is minus 180. So how far away must this be? It must be 30 away, going in the negative direction. So it must be minus 210. Be careful on all these. So many students would write maybe 390, or might actually accidentally write minus 150. So just be a little careful. That's minus 180, it's 30 that direction, so minus 30. This case, this is 0 and it's 30 this direction, so that one's 30. In this case, this is 180 and it's 30 in the negative direction. 180 minus 30 is 150. In this case, it was minus 180 minus 30, so minus 210. Who are we left with? Oh, this guy's outside. This one here is what's halfway between 360 and 7 That should be 720. That's 540, I believe. Let me just double check. Yeah, 540, because I have 510 up here and my answer. Oh, I've missed this guy here. So let me get rid of 510 for a moment. How many? I only have 5. So we're at 150. This guy here is 30 away from 360. That's 390. And as I said, this guy is actually, this is 540 here, and he's 30 away that direction. That's 510. There are your 6 answers that fit inside this world. If they gave you a different range, you would have different answers. For example, at the end of a trigonometry question, it'll probably look harder than this. They might tell you, for example, if they told you your answer was between 0 and 180, your calculator will give you the one and only answer, probably. Although whenever you multiply this by a number, 2, 3, 4, 5, that can change it drastically. But sometimes they might say something like A is actually bigger than 720 and less than, I don't know, 1080. It's going to change your answer. You're going to have to just use your calculator to get this first idea, and then use your brain to figure out where it actually is on this scales. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, part B, they give us this drawing here along with this function. This function is this drawing. And they ask us, what do they ask us? Oh, the period and the range. What's the period of this and what's the range? First of all, just so you know what the period is, it's how often it repeats, or sorry, not how often it repeats, the length of its, the time it takes to repeat, basically. What's this length here? What's this length? How much between repeats, if I'm saying that correctly. And then the range. The range is the height, the highest point and the lowest point. Yeah, sometimes it's the length between them, but they've asked it, so it's like that. Okay, that's out of the way first. Let's go back to just figuring out what's going on here. These sharp edges should be of interest to you and stuff. Right, the trick here is understanding this function. You should know a lot about sines. You should know what they look like when you multiply by 4. What's new and interesting this one is the absolute value. And that does change things. That's where these sharp edges come from. So the highest point a sine can get, the lowest point a sine can get. We should know a lot about them. Let me just draw sine again over here. Here's sine. The highest point sine gets is 1, and the lowest point it gets to -1. Although in this case, it's going to be multiplied by 4. So the highest will actually be 4, and the lowest will be -4. But wait, there's an absolute value. An absolute value does really interesting things. Let's write that again, I guess. That's sine. The absolute value of sine x, let's put an x there. The absolute value of sine x does something special. It doesn't change the first bit. But absolute values do not like minuses. They in fact just make them go back to plus. So instead of being down there, it's going to just bounce right back off. Bounce right back off. Like that. So that'll be, so this first, let's write in some numbers here. 1, 2, 3. 1 will stay, nothing will change there. 3, nothing will change. This 2 will have flipped up between sine and sine x. 4 sine x doesn't really change anything, it just gets taller. Instead of 1, it gets 4. There'll be no -4, it'll jump up. And then we take 1 away from it. So if we can put all that together, the absolute value of, hell, anything that was in here, to be honest, there'd be nothing you could go in here that'd be less than 0. The absolute value will never allow it. So, but we do know the absolute value of sine can get to 0. The lowest it'll get is 0, and then we'll take 1 away. So I now know this number here is -1. Because the lowest this can get is 0, and then we take 1 away from it. What's the highest it can get? The highest this guy can get is the highest 4 sine can get. The highest sine can get is 1. The highest 4 sine can get is 4, and then we'll take 1 away from it. So the highest this can get is 3. That's the answer to the range already. The range is -1, 3. Sorry, put a bracket in there. The next question is the period. The period of sine is, you got to be careful there. They asked for it in radians. They're trying to take away a mark or two from you there. The period is not 360. The period is 2 pi. Just be careful there. They are just trying to get probably 3 or 4 marks off you for no reason there. The period of sine is 2 pi. But be very careful. The period of the absolute value is actually just pi. Because look, it repeats much more often now. It took 2, this 1 up and 1 down to repeat. And this time the 1 down becomes an up. So it repeats every pi. So this guy should repeat every pi as well. There's nothing special here. Multiplying by 4 doesn't change how much it repeats. Taking 1 away doesn't change how much it repeats. So this number here should be pi. This here, 2 pi, and so on. So the period of this is pi. It repeats every pi. So yeah, they're the wrong order. So period is pi, range -1 and 3. Okay, that's it for part B. Let me clean this off and we'll do part C. Okay, for part C, they give us what looks like a simple question. We have a triangle, 3 sides there, they shade in one of the angles, and they ask us not to find this angle, but to find the tangent of this angle. I'm just going to name it theta. You can name it X or A or whatever you want really. I'll call it theta for now. This should be a very straightforward question. The only difficulty comes in is that they tell you not to use a calculator. But you can leave your answer in a fraction form and square root form. So how do we go about that? Well, let's just try it and see if we get stuck anywhere, would be what I'd usually suggest. So they tell us use the cosine rule. So let's use the cosine rule with this angle. So the cosine rule looks just like Pythagoras theorem. It starts off with the angle opposite, sorry, the length opposite this. So in this case it's 2 squared. And they tell us that's equal to the other 2 sides, 3 squared plus 4 squared. A lot of you may not have realised the cosine rule looks like Pythagoras theorem, but it starts this way. But there's no right angle here, so we have to adjust it. And the adjustment comes from that -2 times this length times cosine of the angle we're talking about. That's the cosine rule. It's actually just Pythagoras theorem. If this was 90, cosine of 90 is 0, and it turns into Pythagoras theorem. So it's very similar. If we clean all this up, let's see, we get all the numbers over the left. We get 4 minus 9 minus 16. Let me just go to my notes here. I believe that'll come out as minus 21. Equals, we'll leave cosine on this side, cosine theta, and we'll divide this. 3 times 4 is 12, times 2 is 24, or minus, because there's still a minus there, minus 24. Minuses obviously cancel, and we're left with cosine theta is equal 21 over 24. Oh, I'm sorry, with these 3 goes in both of these. 7 over 8 equals 7 over 8. If you were allowed to use your calculator, it'd be straightforward. You just get theta equals, put in your calculator, then get tangent of that, and you'll get your answer. You get a perfectly correct answer. The examiner's wise to that. If they don't see any work from this point and you've just used your calculator here, you're not going to get any marks. Even though you got a correct answer, you're not going to get any marks on that point. So how do you do this without a calculator? This is how it was done before calculators for many times. Let's draw this triangle again. Well, I won't draw a triangle. I'll draw just the angle this time and an unknown length. But I'll turn this into a right angle triangle because we know cosine theta, this is theta, is equal to 7 over 8. And I know a lot about cosine theta if there was a right angle. And I can easily make a right angle anywhere I want. Here or here or here. Anywhere I want. I'll just we'll take this first one as the drawing. And I know cosine of an angle is equal to the adjacent angle, the adjacent length divided by the hypotenuse. This length divided by this length. And I have 2 numbers divided. 7 divided by 8. This right angle triangle. Let me just rub out the rest of this. We know there exists a right angle triangle. It's bigger than this guy, but it has the same angle as that. that has these dimensions. So if you want to find tan of theta is just equal to the opposite, the opposite over the adjacent. So let's put in a letter here. We haven't used x or anything, have we? Put in x here. Tan theta is actually just equal to x divided by 7. All we have to do is find what x is. And that is actually Pythagoras theorem now. No cosine rule needed at all. This is just 8 squared is equal to x squared plus 7 squared. Or put that another way, that's 64 minus 49 is equal to x squared. What is that? Remember, we can't use a calculator, I'm afraid. So this is 15. That's x squared is equal to 15, or x is equal square root of 15. You could, no, I can't say anything I could take out of that to make it any simpler. That's just what x is. The final answer then is tangent of theta, or they asked for CBA. Tangent, they won't mind, you just write in theta, is equal to square root of 15 divided by 7. And I think they were happy with it in that form. Let's see, they wanted square root of n divided by m. I don't think 7 or 49 doesn't go into 15, so we can't get it any simpler than that. And that's the answer to that question. Much easier with a calculator, but not that hard without it. Just this one right angle triangle trick that was very common before calculators got so good. And that's it for the entirety of question 6. If you have any follow-up questions, or if you see any mistake I made, want to point it out to me, let me know in the comments. Do me a favour and put in the timestamp. It helps me answer your question. Thanks for watching and have a great day.